अच्छा जी। क्वेश्चन नंबर 4 है पेपर 2 का मेंसुरेशन का। ठीक है, ईयर भी देख लेते हैं। सो द ईयर इज बेसिकली नवंबर 2012, पेपर 2 क्वेश्चन नंबर 7। ठीक है जी, नवंबर 2012 पेपर 2 क्वेश्चन 7। क्वेश्चन नंबर 4 है बुक का, राइट। अच्छा, बोल क्या रहा है वो इम्पोर्टेंट है कि a cylindrical open container has a diameter of 21 centimeter and the height of 8 centimeter. Now, you already know that it's a cylindrical, an open container has diameter of what? 21. So, if the diameter is 21, so the radius is going to be what? 21 divided by 2. So, radius will be 21 divided by 2, right? So what we can have is radius is 21 divided by 2, that is 10.5. So that means we know the radius is 10.5 here. Then it says that calculate the total external surface area of the container. Now total external surface area. Now what is surface area? I have always been telling you that your surface area comprises of what? Total, that means the base area, right? The base area and the curved surface area of the cylinder. Because the normal cylinder is like this, right? So when we talk about total surface area, so this is your circle pi r square, this is your circle pi r square, and this becomes your curved surface area, that is 2 pi r. ठीक है जी। पर यू नीड टू अंडरस्टैंड कि इसमें जो है आपको बोल दिया ओपन है, इट्स एन ओपन सिलेंडर। सो दैट मीन्स द top thing is missing now. So when the top thing is missing, so what do we have here? So that means we have a circle at the bottom. So pi r square for the circle and 2 pi r h for the curved surface area, because curved surface area will have what? 2 pi r h and pi r square. So if we just put down the values, that is pi 10.5 square plus 2 pi 10.5, and the h is 8. H is 8. So if you just know that your normal height is what? 8. So if we just put down this thing in the what calculator, we'll find out the total surface area, that is 874. Your total surface area will be 874 because it's paper 2. So eventually we can use what calculator. So 874 is the answer for the first part. Now, what does second part say? Manufacturer what receives an order of 30,000 containers. How many? 30,000 containers. He needs an extra 150 centimeter square of the material for each container to cover the waste. For each container to cover down the waste. So how much total surface area we had initially? Initially we had 874 surface area required for this container, right? But this is for one only. But we will add 150 more because 150 extra is required for the wastage. So the total surface area for each container would be 1024 centimeter square. Now the question says calculate the area material needed to make these containers. Now and give your answer in meter. Now this is important. Give your answer in meter. Since I need to give this answer in meter, remember this: 1 kilometer is equal to 1000 meter, right? 1 meter is equal to 100 centimeter. 1 centimeter is equal to 10 millimeter. So when we are talking about centimeter being converted to meter, so this is mean 100, right? Obviously, centimeter conversion to what? 100. So that means if we just work upon this, that when meter is converted to centimeter, it will be what? 1 meter is equal to centimeter, it will be 100 centimeter. But if we talk about centimeter square and meter square, so this would be 100 into 100. So 1, 2, 3, 4. So we need to divide it by about 10,000. But we'll be dividing what? We'll be dividing the total material needed because that will be in the centimeter square. So what you need to understand is 1024 was for 1. This was centimeter square. Multiply by 30,000 containers needed, right? So when we multiply, we end up having what? 0372 and 40 centimeters square. But since I need to what? I need to change this to what? Meter, square meters, right? So obviously, when I'm converging my centimeter to meter, I'm going from a smaller unit to a smaller unit to bigger unit. When I go from smaller unit to bigger unit, what I do is I divide. So how much I'll be dividing? I'll be dividing it with what? 10,000. Because centimeter, 1 meter to centimeter is 100, right? But if it is square, it will be 100 into 100, which means 10,000. So 1, 2, 3, 4, 1, 2, 3, 4 are cancelled out. So this means 3072 meter square of material will be needed for what? 30,000 containers. So I can write this 3072 here. So this was part 2. Part 1 was of 3 marks, where we were required to find out the total surface area. Your total surface area included what? It was an open container. So open container means only pi r square for the circle and 2 pi r h. What is total surface area? Total surface area means surface area of all the side, area of all the sides. So we have 2 sides only. Then when we got to know part 2 says 150 was the extra material required because it was wastage. So 874 was the initial, 150 was added. So in this basis, it was 1024 centimeters square. And then we multiplied it with 30,000 containers because we need to find out the total material required. But in the end, the examiner clearly says give you answer in meters square, right? So square meter. So what we need to do is we need to reinitiate the values that 1 meter is equal to 100 centimeters. So 1 meter square will be what? 1, 2, 3, 4 centimeters square because 100 multiplied by what? 100. So this will be when we go from smaller unit to a bigger unit from centimeter to meter. So what we do is we divide. So we divide it by 10,000 and what we got is 3072 meters square. Fine. Now in the next part, the question gets more interesting. It says that the surface area of the sphere is 4 pi r square. Fine. The volume of the sphere is 4 upon 3 pi r cube. The circle top, remember this. The circle top that can hold up to 4 hemisphere balls can be placed on the container. That means on the top. Fine. So this is your container and the top. This becomes what? Cross section of the normal base. Now that means this is your height. And in this we can find out that there are two spheres in the one side. So let's just work on this. The top of the circle of the diameter 21 centimeter with 4 circular holes of the diameter 7 centimeter each. A hemispherical ball of the diameter 7 centimeter fits into each hole. The cross section shows 2 of these balls. Now, The calculate the inside curved surface area of one of these hemispherical balls. Now, you need to find out this is only what? Hemisphere. This is hemisphere. So, hemisphere is half sphere. And we are talking about surface area. So, sphere surface area is 4 pi r square. It is already given here. So, hemisphere will be, it will be half. So it should be 2 pi r square. It should be 2 pi r square. Now, when it is 2 pi r square, so what does it mean? It clearly identifies that we need to find out that this is 2 pi and the radius for each is 3.5 because your hemisphere has what? Diameter of 7. So radius will be 3.5. So if it is 3.5, so this was what? 4 pi r square. So this should be 2 pi r square now. When it is 2 pi r square, so it means it is 76.98. This will be 76.98. So we can round it off to what? 77. So this will be 77 centimeter square. You can write down both answers here. 76.98, rounding it off to what? 77. Now remember this is just the answer for one hemisphere. One hemisphere surface area. One hemisphere surface area. Now in part 2, calculate the total surface area. Calculate the total surface area of the top of the container, including the inside curve of the surface area of each ball. So we need total surface area of the top of the container, included the inside curved surface area of each bowl. Now, to be fair enough, what you need to understand is the total surface area. So if you just look at this shape, can we just understand the concept behind this? That the total surface area of the entire thing involve what? These are the inside, right? These are the inside path. Can we see 21.21 here? So your radius will be 21 upon 2, which is 10.5. And when we work upon the entire thing here, so that means it will cover up the total circle. It will cover up the total circle. So what I need to do is, what we can just take this, that we can add up the entire circle, right? Because obviously it covers up. But remember, we need to have the inside hemisphere as well. So inside hemisphere will be one hemisphere area multiplied by 4. But what you need to understand is these are 4 open hemispheres, right? The top of the circle is diameter with 4 circular holes of diameter 7, hemisphere ball of 7 fits in each. So that means we do not need these top of the circles. So we will subtract these circles from the entire circle. That means only the top part will be taken, but we will be taking the inside surface area, which will be through 2 pi r square. And then we'll be multiplying it with 4. So what do we have? So we can just take this using number 1, area of large circle. Your area of large circle means pi r square, which will be pi, and the diameter is 21 upon 2 square. So this should be 441 upon 4 pi, right? Then what we need to do is, we need to have 4 small circles on top, which needs to be subtracted. So pi r square again, but the diameter here is 7 upon 2 pi. And then we will multiply this by what? 4. Why do we multiply by 4? Because there are 4 small circles. So what we'll be getting is 49 pi. But we need to take 4 hemisphere. That means inside circle, inside hemisphere. So 2 pi r square. That means 2 pi r square multiply by what? 4. So which means this will be 2 pi 7 upon 2 square multiplied by 4. We'll end up having what? 98 pi. So what do we have? 441 upon 4 pi minus 49 pi plus 98 pi. So what we'll be getting is 500 centimeters square when we'll be calculating through the calculator. So this is the total surface area of what? The top, which includes, this is your circle, right? And we are excluding the 4 circles at the top. So we'll be getting what? We'll be getting the surface area of the top, which is here. And then what we will find out the surface area of hemisphere, which is 2 pi r square. We multiply by 4 because there are 4. So this radius is 3.5, that is 7 upon 2. And this radius is 10.5, which is 21 upon 2. So this was part 2 of the same question. Now it says with part 3, with the top and 4 balls in place, calculate the volume of the water required to fill the container. Now, you need to understand this. It's very important to understand that what is happening here. Let's just work it out in this way that, let's say we have a container, right? And 1, 2, 2 containers are filled from this side, and obviously 2 containers will be filled from the other side. And this will have this thing, and similarly these 2 balls will have. And these are placed inside the cylinder. Now what will happen is that if the water is filled in, the water is filled in. So obviously the water will be filled in around the hemispherical, 4 bows. So that means it will not fill in these bows. It will be around these. So what we are going to do is, we are going to take out volume of cylinder. We'll be subtracting volume of 4 hemispheres, because we do not need these volume. The hemisphere will not be filled in with water. Only the cylinder will be filled in. So what is the formula of cylinder volume? Base area into height. Base is of circle, right? Your base is of what? Circle. So this will be pi r square h, base area into height, minus 1 upon 2, and the volume formula is 4 upon 3 pi r cube. 4 upon 3 pi r cube, and this thing will be multiplied by what? 4. Why are we dividing it by 2? Because we need volume of hemisphere. So eventually we'll find out that we'll be having the volume of the 4 total surface, total volume of the cylinder that has the water. So pi, this will be 21 upon 2 square multiplied by 8 minus This will be 2 upon 3 when we cancel out 2 ones are 2s are, and this will be 8, 4 2s are is 8. So 8 upon 3 pi, and the R is 3.5 cube. R will be 3.5 cube. So the total volume cylinder is 882 pi minus, this will be 343 upon 3 pi. So the end result for this is 2412, which will be 2410 centimeter cube. So 2410 centimeter cube is the end result. So what we're going to do is volume of the cylinder minus volume of the four hemispherical balls that are inside the cylinder, which will cover down the water that is being put down in the container. So this was the question which was from November 2012, paper 2 question number 7 of the entire mensuration, considering that this is question number 4 from my book.